Hello, guys. Welcome back to Maths Zone African Motives. We are still on our mathematics N4 and working on our revisions. This is an important aspect as you have covered the basics of each and every topic as an individual, which is very, very important that you do so before you attempt question papers. Make sure that you know the basics of each and every topic that is in your syllabus. So this is an exam which is from our November 2025 exams, those November exams. So it was, that is the question paper actually that we are going to look into. And it was 3 hours out of 100. And you must read all the questions carefully, answer all questions, and you must also number according to the numbering system. All right, all final answers to be rounded off to 3 decimal places unless indicated otherwise. So you see, these are some of the instructions that these department people, they sometimes do not follow. When you check the memo, you see rounding off answers to 2 decimal places, then you'll be surprised what is happening. But you must follow the instruction, all right? 3 decimal places, that is what you're given there. That is what you are given. So we are going to look into our question paper. These are the questions, all right, that you had. So make sure that you also have the question paper. And some of us have been asking about the study material that you can use. So if you to need the study material, guys, what you simply do, you don't need to WhatsApp for that. You can simply go straight forward if you are on your browser, Maths Zone African Motives. All right. So if you enter here, I want us to see this part. All right. I want to thank all the members for joining, guys. Let us join membership. It is one of the most important aspect that is that you can use when you are to consider revisions. Because if you check, there are some videos that you cannot access if you are not a member. It is only under membership, like these ones, members only. So if you check that part, it is important that you do join the membership so that you get access to those videos. All right, so like I was saying, if you need files, documents that you're going to use for your engineering, all right, what you're going to simply do, you tap on this part, which is YouTube, what, and 13 more links. I don't know on your side, it's going to show how much, because we're going to add as time goes on. But if you check on that part, all right, if you are to click on that part, just tap on that part. Is it click or tap? All right, let us tap where it is written and 13 more. So just going to tap that one. All right, so if you check here, it gives us the description and the links here, the links. These links are the ones that you can use. All right. One, you can even join membership from there. All right. So if you go down, all right, let us go down. I'm using this one, this thing here. If you are using a computer, if it is on a phone, I think it's just scrolling down. All right. So if you go down, you'll see that there is a drive which is meant for netted engineering. This one, netted engineering. All right. It's for yours now. This is your folder. This is your drive. So you tap that drive. All right. You tap inside. Once you tap inside, it's going to show you all the files that I have for netted engineering. So it will depend with time, I'll be updating and so on and so on. So if you tap that, yeah, netted engineering, if you just tap this blue thing, that link, it will take you to the drive. When you're inside the drive, you can download any document that you see there, any document. So if there are question papers, if there are textbooks that I have, you can download from there. It is for free. It is not paid. You download them for free. You don't need to be a member to access the drive. Anyone can access the drive. I have given an allowance that you can simply download anything from there, textbooks, question papers. All right. Then, all right. So that is it, guys, for those who need the files. Then I also want to consider this part before we answer our questions. I also want to take this opportunity. Let me also answer some of the questions that others have been asking. All right, some of us have been asking, they are failing to join the membership. If you check now, YouTube, as for now, gives allowance to join the YouTube section if you are in what? South Africa, because my account is, I created this account in what? In South Africa. So anyone in South Africa, you can join as long you have got your credit card, those debit card. Yes, you can use those ones. You can join the membership. So when you're outside of South Africa, you see that it is impossible for you to join. If you try to join, it can just be referring back to the home, or it can even state that it is not yet introduced. This service is not yet introduced in your country. This and that. I have so many people from Namibia that have been actually having that problem. They are willing to join the membership, but they cannot join the membership. So you can only join if, let's say, you create your Gmail with a South African number. So what you can do is, maybe you've got someone in South Africa. All right, they can you can create a Gmail. It's just issue of the number to say you are using your phone on your side, and when you enter that number, now the person is going to give you the code. All right, the person is going to give you the code, then you enter that code on your side. So it'll be like it is what? In South Africa. All right, that is the case. So you also change, if you check inside, you can even change the addresses and so on and so on. You can put any South African address that you have. It will be taking you as if you are in what? You are in South Africa. So mostly it is difficult because you might not even have someone that is this side. So it is a challenge mostly for those who are outside of what? Of South Africa. So what you can do for those who need those videos that are under membership, for those who need those videos, contact me. All right, you contact me so that I can find a way of sending those videos to you. All right, so you simply need to contact me, then I'm gonna find a way of sending those videos, because most of us will be in need of those videos, but you cannot join the membership because you're outside of South Africa. So please contact me. We are going to find a way. There's a way actually that I've been using with others. So what you just need is to contact me. You get the videos as they are on what? On membership. All right. So that is it, guys. I'm very sorry for taking much of your time. And also the last thing, it is about the community section here, guys. The community section, most of us, if you are not on membership, you might not have my number. So please use the community section. It is for anyone. All right, if you visit this community section, you can send any question. You can post a question, like in this case, you can even add an image If you have got an image of the question, you can even upload that image and write what you want, what's on your mind. You write as it is. Can you assist me? This question, this and that. You don't need to be on membership to access that community section. Anyone can access Maths Zone African Motives what community. Anyone can access that. So there's no need for you to need my WhatsApp number if there is a question that you need assistance in. Use YouTube. We met on YouTube, so let us finish all our business here on YouTube. All right, they have access for you to do that. So guys, let us utilize that. Let us utilize that. All right, let us utilize what we are given as a platform. This is where we all meet on this platform, so we can send those questions here on this platform. All right, so yes guys, sometimes questions, I'm gonna maybe take some time to attempt your questions, but send those questions there, post your questions. Even if you have got a solution that you think, all right, let's say I answered this question or I answered this question, then you have another way that you think it could have been done. You can utilize also that community section. What you simply need is to what? Work out the way that you think. All right. Then you post it on the comment section. You can even copy the link of the video where it was taken from so that I can relate to that video, or you can just write the title of the video. The title of the video as it is, so that I can visit that and check according to your calculation. Because this is like a distance learning. We cannot meet. We cannot have a section where we meet one-on-one. So what you think, don't let it, what can I say? Whatever that is in your mind, this platform is there for you to express it. Express what is in your mind. We correct each other where there is a need to correct each other. If that is correct, then we move on. You know that you can use that method. It is valid. You can apply it. So let us utilize the platform that we are using. It is the community section. It is the comment section. The comment section on its own. It is meant for you. Comment there where you do not understand, or where you have got a certain way of presenting your answer, so that we can relate. Someone can even answer you from anywhere, because it is an open platform for anyone. I might not be the one to answer you. So even if you are guys, you are reading comments and you see that this person needs a help, maybe I did not see that comment, because there'll be a lot of comments that will be coming on a single day. Maybe you saw that and you can assist that part, answer that person. All right? It is our platform. It is not my platform. It is your platform. Everything that I'm doing is for you, not for me. So utilize it as a family, the family of light. Anything that you do not understand, send it there. When I have time, guys, I'm going to look into those comments, into the community section. So do not lose hope or patience. Just be patient enough. I will go through that. All right. So without much said or much to be said, let us quickly look into our questions. Question number 1. You were given this part on our functions and graphs, which is 10 marks. And 1.1, you are being asked to draw a neat sketch All right, it must be a neat sketch of y plus the square root of 9 minus x squared is equal to 0. What type of a graph is this? Y plus the square root of 9 minus x squared, and that's equal to 0. We can see that if we were to expand this and that, this layout brings back to a circle. But in our case, because here we are given a single sign, it will be a half circle. It is not plus or minus, it's just a plus. All right? So what is the best way of presenting? We are supposed to write it in the form y is equal to whatever that you're going to have here. Is it a plus? Is it a minus? But we are going to have the square root of r squared minus x squared, where r is the radius. So we can see this is exactly what we have. If we can just take this plus to the other side, it will be a negative square root of what? 9 minus x squared. Exactly the format that we must have for a half circle. It can be a plus or it can be a minus. So you must have one side, not both, but just one side. If there are two, it means you are referring to a circle. So it's just one sign that you must have, either a plus or a minus. So here we just have a single sign. So we know that we have got what? A half circle. Where r is the radius from r squared. So 9, remember, it can be written as what? 3 squared. So this is the same as minus the square root of 3 squared minus x squared. From this format, guys, the format on its own, it tells us that this is our radius. So we are going to have a semicircle of a radius 3 units. But where exactly are we going to have this semicircle? When we are given y is equal to a negative, it's a half circle that is below the x-axis. It is a half circle below the x-axis. When you have a positive, it will be above. But this one, it is below the x-axis. So if you know, guys, that you're dealing with a half circle, just present your half circle, then you indicate the values that you are going to have as what? As your intercepts. Remember, it is a half circle or a semicircle of what? Radius 3 units, meaning to say from the origin to this, we have got 3 units going down, so that's a negative 3. From the origin going this side to the circle, we've got 3 units, and this side 3 units again, but this is what? Negative 3. So that was the case. We are given what? A half circle there, a semicircle. Y plus the square root of 9 minus x squared is equal to 0. So that is what you needed on this part. And the question here is that is the inverse of this graph, all right, the one that you had, is the inverse, not the one that you are given here, but its inverse. Is it a function or a relation? So the question is, what is the inverse of this half circle? What is the inverse of this half circle? The inverse of this half circle that we are given or that we are having in our case, it is simply from the half circle that we have, and it will be also a half circle, but this one, it will be x is equal to minus the square root of 3 squared minus y squared. Remember, I explained, guys, on the introduction of a semicircle that the inverse of a semicircle is a semicircle. So this one, it is a semicircle that we are going to have. It is a semicircle that we are going to have, but it is presented x is equal to minus. So we are going to have this circle, this semicircle in the x side, all right? We are referring to the x as a negative. So we're going to have this to the left side like this. All right, so this will be negative 3, guys. The radius is still the same, negative 3, positive 3. So as you can see, this is our inverse. This is our inverse. Is it a function or a relation? From our vertical line test, you can see that it passes through the graph that we are given at 2 points. So it's not a function. If it is not a function, it means it's what? It is a relation. So our question, our answer was supposed to be a relation. And is this inverse, not the original graph, but the inverse of this graph, continuous or discontinuous? Is this graph that we've just drawn now continuous or discontinuous? It is a continuous. There is no lifting up of the pen when drawing that piece. So it is what? A continuous. It is continuous. It is a relation being what? Being continuous. All right, so that was the concept of that part. Then we move on to the other part, 1.2. You were being asked now to draw a sketch of the graph. All right, so 1.2, we need to have a sketch of the graph. 9x squared is equal to minus y squared plus 36. So if we check properly here, we can see that this was going to give us the format of an ellipse. 9x squared, if you take this to the other side, is what? Positive 4y squared, which is equal to 36. If you take note, these two are different. This is 9, this is 4. The moment that you see this part of x squared and y squared different with a positive, we know that's an ellipse, which we know that it can be written in the form x squared over a squared plus y squared over b squared, which is equal to 1. So meaning to say, if I can present in that format, the x values will be taken from A, the y values will be taken from what? From B. To say x is equal to A, y is equal to B, if you can write it in this format. So what you need is to simply have what? A 1, this one, on the right-hand side. So how can we obtain a 1 on the right-hand side where there is what? A 36. You have to get rid of that. So what can we do? To obtain a 1, you must divide by what? 36. Each and every part, you must divide by 36. So that this becomes what? A 1. So it was going to be 9 over 36, which is 9 into 9, that's 1, into 36, that's a 4. 4 into 4, that's 1, into 36, that's a 9. So it was going to be x squared over 4, and 4 is same as what? 2 squared, plus y squared over 9, but 9 is same as what? 3 squared. Remember, we need to write in the form a squared, b squared, where we know if it is in this form, x is equal to a. So in our case, x is equal to what? To 2. And y is equal to what? To 3. These are the intercepts that we are going to use, knowing that it's an ellipse. So this is just like plus or minus, plus or minus. That is the case. Plus or minus, plus or minus. So if you are to present this, x is an intercept at 2. So this is 1, 2, 3, minus 1, minus 2, minus 3. All right, just pardon my spacing, guys, because if you check this spacing, sometimes it might not give us exactly what we want. All right, so this is something like this that you're going to have. So x at 2, it means we're going to need positive 2 and negative 2. Y at 3, we're going to need positive 3 and what? Negative 3. So you're simply going to join and have what? Your ellipse. So just pardon my points, guys, the way that they are separate, but you know your ellipse, how it looks like. All right, so it was 9x squared is equal to minus 4y squared plus 36. You just write the way that you're given there. You are done. All right, then you're being asked What is the domain of this graph that you've just drawn? The domain on 1.21. We talk about the x values here. So the domain referring to the x values, we are going to have x is such that, all right, let us refer to the x values. The x values, they are limited from -2 up to 2. They are limited. We cannot have a value outside of that. From -2 up to 2. So it means x is greater than or equal to -2, but less than or equal to 2 in within that within that domain. That is where we are having our x values. They cannot exceed that. So from -2 up to +2. And 1.22, it was now to, what is the range? All right, now it is to determine the range of that same graph that we had. So the range referring to the y values, these are y values. So in our case, y is such that y is limited again from -3 up to +3. It cannot exceed that. It is limited in within that. So y is greater than or equal to -3, but less than or equal to 3. So that is our range, just like that. So you're going to obtain full marks. All right, so that was it, guys. Let us move on to question 1.3, which was to draw a neat graph of y is equal to the log of x in the base of e. All right, so we have done the introduction about these graphs, guys. A logarithmic graph, when you are given it in this form, y is equal to the logarithm of x in base of e. Our e, remember that e is equal to 2,17. E to the exponent of 1 is 2,718. 2,718, something like that. 2,718, which is a number that is what? Greater than 1. So when we have got the base, our a from k logarithm of nx in base of a, if this a is greater than 1, and our n here is a positive value, a positive integer, it means we are referring to a logarithmic graph of this nature. Remember from our introduction. So that was simply what you have there. You can rewrite it as an exponential. You can rewrite it as a ln. Y is equal to ln of x, whatever that you want. But this is what you're going to have at the end. All right, so your graph was going to be like this. That's a logarithmic where it crosses the x-axis at 1. This value of x is 1, so it's not going to change. It is just going to be a 1. Remember, I told you if there is a 3, it's going to be 1 over 3. If there's a 2, 1 over 2. So this is 1, so it's 1 over 1. Does not change, it's just a 1. So that was the graph of y is equal to log x in base of e. Sketching of graphs, guys, you just need all the basic of that graph. That is the sketching, and it's going to be a repetition throughout. Repetition throughout. So you just need to know the basic of each and every graph in your syllabus. That was our question number 1. Let us move on to question number 2, which was part of our determinants and also the complex numbers to make it 20 marks. All right. The first part, 2.1, solve for x. Solve for x. This is the determinant form, all right? From our introduction, guys, I have referred such, so you just need to go through those introductions. How to determine a determinant. This is order 2. A, B, C, D. The determinant is equal to the product of the major diagonal AD minus the product of the minor diagonal, which is what? Which is BC. So this is how you're supposed to obtain the determinant. But in this case, you are given it is equal to 4. So solve an equation. The same way that you to simplify your determinant, you do it. The major diagonal, 3 and x, minus what? The product of the minor diagonal, minus 1 and 2. So that is it, minus 1 times 2. This is supposed to give you a 4. You are already having the answer to that determinant. So that is it. As we can see, we have formed an equation, so we can solve for what? We can solve for x. 3 times x, that is 3x minus, this is negative 1 times 2, which is negative 2, which is equal to 4. Negative negative is going to give us a positive. So as we can see, guys, we are dealing with a linear equation. So simply eliminate or get rid of these two, subtract it. That's 3x is equal to 4 minus 2, which is 2. To find x where there's a product, simply divide. So that's x is equal to 2 over what? 2 over 3. All right, an easy question. 3 marks for that. All right, it's an important, not easy, but important for us to learn. 2.2, given that x is equal to this, x is equal, solve using the method of what? Cramer's. All right, so remember the Cramer's rule. I told you guys the first thing is the format that you are going to need. A1x plus b1y is equal to c1. A2x plus b2y is equal to c2, where x and y is one side of the equation, constants on one side of the equation. So you had to rearrange those equations in that manner. All right, let us start with the first equation. What we can do here, x is equal to minus 3 over 2y plus 9 over 2. Yes, you can just take this one to the other side. You work with the fractions if you want. You can work with those fractions. But as for me, guys, I do not like these fractions, so I can get rid of these fractions. This is 2, this is 2. So I can simply multiply this one by 2, by 2, by 2, the LCD of our denominators. So it's going to be 2x minus, is equal to, this one cancels. So it's going to be minus 3y plus 2 and 2 cancels. You're going to remain with what? 9. At least I do not have fractions. Then I can rearrange. Remember, we need x and y on one side of our equation. So that was going to be 2x. We take the minus 3y to the other side. It's going to be what? Positive 3y. And that is equal to this 9, which is already on the right hand side, and it's what? A positive. So that was it. This is our first equation. First, we have to rearrange. Right. Then on the second one, we do not have fractions there, so just rearrange. X already on the left hand side. Take the 4y to the other side. It's going to be a negative. So that's negative 4y, which is equal to 2, positive 2. So that is our second equation. Just like that, we can solve for x and y using the Cramer's rule, as we do understand that x is equal to delta x over delta naught, and y is equal to delta y over delta naught. We need to find determinant of x, determinant of y, and determinant of what? The coefficients. All right? Just like that. So how do I determine delta x? I simply have to close this part of x and replace it with what? With constants. So I cover this up, replace it with constants, 9 and what? 2 as they are. So that was the case. So we're going to replace the part of x with constants, 9, 2. But the part of y remains as it is. X is the one that was affected. Y remains as it is. We need the coefficients, 3 and what? Minus 4. All right, so this is our delta x. We can simply solve it as we have done before. The product of this major diagonal, 9 times negative 4, minus the product of the minor diagonal, 3 and what? 3 and 2. That was it. So our delta x is going to be negative. All right, just simplify everything, guys, but you can just obtain negative 36, negative 6, which is going to give us negative 42. So we have got our delta x. And we move on to the part of y. We're going to need to find its determinant. All right. So this one, we are going to close the part of y this time. So y is the one that is affected. We close it and place the constants. All right. We place these constants. So meaning to say x is not affected, but it is the part of y that is affected. X, we're just going to take these coefficients as they are 2, 1. And y is being what? Affected. You must use the constants 9 and 2. So that was it. We're going to have our delta x here. 2 versus 2. All right. 2 and 2 in the major diagonal. 2 times 2 minus what is remaining? 9 and what? 9 and 1. So that was it. We are going to have our delta y, which is 4 minus 9, and that is what? Negative 5. Then moving on to our delta naught, which is for the coefficients. It means you are going to refer to the coefficients as they are for x and y. The constants are not to be substituted anyway. All right, you take your x as it is, your y as it is. So what are the coefficients of x? 2, 1. The coefficients of y, 3 minus 4. Just like that. You can determine your determinant just like before. 2 and negative 4. That's negative. All right, let me multiply 2 times negative 4 minus 3 versus what? 3 versus 1 in the minor diagonal. So it's going to be negative 8, negative 3, which is negative 11. So this is our delta naught for the coefficients. So using our Cramer's rule formula, x is equal to what? Delta x over delta naught. So x is equal to delta x minus 42 over what? Delta naught, negative 11. So that was going to give us the value of x, which is 42 over 11. You can have it as a decimal if you want. And y is equal to what? Y is equal to delta y, negative 5 over delta naught, which is negative 11. So therefore, y is going to give us 5 over 11. All right, so that's 5 over 11. So that was it for the value of x and for the value of y if we are to use the Cramer's rule. So like I said, you could have worked with those fractions. It is in your hands. If you want, you can just use those fractions as they were here. Still, you're going to obtain same answers at the end. All right, so that was it. 5 marks to solve. 5 marks. Let us consider another part, 2.3. We are given to convert this to rectangular form. We are now back to our complex numbers. All right, let's see what we have got here. That's 2.3. All right, 2.3. All right, so this is given as 4. All right, what if I just do it here, guys, so that I do not waste this space here. All right, so here we are given 460 times 100. Remember that this year, when it is a product, you multiply the magnitude that you are given here, all right, which is the modulus that you're given. You multiply these, then you add the arguments when it is what? A product. So that is the case. You're just going to multiply 4 times 8. Then as of the angles, you are going to add 60 and what? 60 and 100. You add the angles. Division, you subtract, but multiplication, you add. So this is over what? 2 cos plus I sine theta. Remember, this year is another format or way of presenting the same thing. If you're given cos, let's say, all right, let's say we have got this. Z is equal to R cos theta plus I sine of theta, which is this format that you're given. It is the same thing as writing it as r cis theta. It is the same thing as writing as r angle of theta, like that. So it's the same thing. So what is our r there? Our r is 2. This number that is outside this represents our r. So it was going to be written as 2 cis what? Theta. What is our theta? Theta is the angle that you're given, 30 degrees. So that's 2 cis 30. Just like that. It's just converting to the format that you have used above. It's just conversion. All right. So that was it. 4 times 8, that's 32. Then the angle you're going to add 60 plus this, that's 160 over 2. Then our angle here is what? Is 30. All right, we are back to a division. Remember, on the product you multiplied, you added angles, but this time you are going to divide these two. 2 into 32, that's 16. But as of the angles, you subtract for a division. So that's 160 minus 30. All right, so it was going to give us 16 cis 130 from there. All right, that's going to be 130. Remember, they told us to convert to rectangular form. Convert to rectangular form. Remember what I just what I was presenting here: r cos theta plus I sine theta. We say it is the same as what? R cis theta. So we are converting it to this format. So we are going to have this one as what? Our r is 16. So it's going to be 16 cos of what? Of theta. Our theta is the angle 130. Cos 130 plus I sine theta. Our theta is what? 130. So this is what you're going to have. 16. We can expand this one and simplify. 16 times cos is going to be 16 cos 130. 16 multiplies here, so it's going to be plus 16i, or you can just write I like this. 16 sine of what? Of 130. So you have expanded by 16 in the bracket. Then simplify each term separately. 16 cos 130 is going to give us what? All right, so 16 cos of 130 is going to give us negative 10 point. All right, let me just fix my calculator to to 3 decimal places as we are given. So that's negative 10,285. Negative 10,285. All right, then this part of I here, you simplify it. So you simplify this 16 sine what? Sine 130. So this is 16 sine 130. And that was going to give us 12,257. That's a positive. So that's positive I there. With the is I there. Positive I. And we have got this one, 12,257. Just like that. This is rectangular form. These two cannot be combined. You cannot add them, these two, because this is either separating the real and the imaginary rectangular form. You must see that real and imaginary. So in place of I there, you can even use a j. It is up to you. You can apply a j or use I. All right, so do not worry about that. Anyone, that was the case. So this is our final answer, guys. It cannot be simplified any further. All right, it cannot be simplified any further. Let us move on to another question. That was 2.4, and it is having 6 marks. All right, let's see why is it like that. 2.4, solve for x if we are given x cubed minus 8 that is equal to 0. Solve for what? For x. All right, so this one, we you can see that there is a cubic. You're given a cubic equation, but the format that we have is this format of a cubed minus b cubed. Remember the factorization of a cubed minus b cubed, which gives us a minus b into a squared plus ab plus b squared. So this is the factorization that we can actually use. So as we can see, 8 can be written as a number to the exponent of 3. 8 is same as what? 2 cubed, right? 8 is equal to, then shift, you press fact. That's 2 to the exponent of what? Of 3. So it is the same as it was written as x cubed minus 2 cubed is equal to 0. So we can have our a and our b, a and b, as we are given here, a and what? A and b. So if a cubed minus b cubed is equal to a minus b, it means here we are going to have x minus 2a minus b. So that's x minus 2 into what? A squared from that first term from this. That's our a. So it's supposed to be x what? X squared. A squared plus ab plus ab, the product of a and b, the product of x and 2. That's what? 2x. Plus, you add. Plus, again, you add b squared. What is our b? Our b is represented by 2. This is our b. But they're saying b squared. So it's 2 squared, which is 4. So you do the factorization. All right. For those who want to dwell much in this type of factorization, make sure that you visit grade 10 videos that I've done on factorization of cubic functions. They're them. So you can check. There are a lot of questions that you can exercise yourself. All right. But that's how you factorize a cubic function of this nature. So as we can see, we have got two brackets. Two brackets. It's a product, this one. Product of two terms equal to what? To 0. If a times b is equal to 0, it means one of these must be equal to 0. It's either a must be equal to 0 or b must be equal to 0. That's the 0 product. So meaning to say it is either this bracket as it is equal to what? To 0. X minus 2 must be equal to what? To 0. Or this bracket, which is being multiplied as it is, x squared plus 2x plus 4, must be equal to 0. All right? Oh, sorry, that's a 0 there, equal to 0. This one equal to 0. So we are at a simpler stage where we can solve for x. The first one, just transpose this to the other side, becomes a positive. So x is equal to what? To 2. What about this one? We cannot use factorization here because already, guys, here we were factorizing. Remember this one. From here to here, it's a factorization. It was factorizing. All right? It was a factorization which was taking place. So meaning to say, when we have applied the factorization, when we say we have applied the factorization, this here is already in simplest form. It cannot be factorized. They were not going to give us a formula where this part that is remaining here can be factorized. If we, no, means it cannot. So don't think about factorization there. Apply your quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac everything over 2a. From the quadratic equation, ax squared plus bx plus c is equal to 0. So you can see coefficient of x squared is our a. The coefficient of x is our b. The constant is our c. So therefore, x is equal to minus b minus 2 plus or minus the square root of what? B squared. B is 2, so that's 2 squared minus 4 times A, which is 1, times C, which is what? Which is 4. Everything over 2A. And our A is 1. So this is it. Do not use your calculator. This is N4, guys. They tempt you. All right? They tempt you on this part. Do not use your calculator to simplify it will give you maths error. Then you see, then you think that this one cannot be simplified. Minus 2 plus the square root of 2 squared minus 4 times 1 times 4, everything over what? 2 times 1. Then it gives you math error. Then you're like, where am I going wrong? Don't evaluate like that. Simplify what is inside of the square root. It is important in mathematics to know what is under the square root. Is it a perfect square? Is it just a normal number? Is it a number that has got a negative? It is important for you to know what is under the square root. So that's minus 2 plus or minus the square root of. You simplify only what is under the square root, this part under the square root only. Don't put the square root. Only the numbers under the square root. 2 squared minus 4 times 1 times 4. These are the numbers under the square root. You are going to obtain minus 12. All right, it's because here I fixed my calculator. Let me go back to normal mode. This is just minus what? Minus 12. So minus 12 here tells us that we are under complex numbers. We are dealing with complex numbers since we cannot determine the square root of what? Of a negative. The square root of a negative, we know that it does not exist. It does not exist. So we are going to use complex numbers idea to say the square root of a negative 1 represents a j, or you can use I. Anyone. It represents a j, or it represents what? I. The square root of a negative. So when you see this negative here, it is the same as the square root of negative 1 times the square root of 12. So the square root 1, this one, the square root of negative 1 represents a j. So it was going to be x is equal to minus 2 plus or minus the square root of a negative, which is what? Our j or I. You can use I or j. Square root of 12 you will remain times square root of 12. Everything over what? Over 2. Square root of I, the on of minus on its own gives us I. Square root of 12, we can simplify that one. Square root of 12 is equal to what? That's 2 square root of 3. So it's 2 square root of 3. So I'm just going to write this as x is equal to minus 2 plus or minus, all right, I there. Then we're going to have 2 square root of 3. Everything over 2. So this 2 here can be separated. We can divide it by 2 here, by 2 here. So it is going to give us negative 1 plus or minus 2 and 2 cancel. So this is I square root of what? Of 3. These are two solutions that you're having. So that is what you're going to have at the end. You can separate that or you can just leave it as it is. But remember, there is that solution that we obtained before. The x is equal to what? The x is equal to 2. So it's part of the solutions here. So we are saying that x is equal to 2 or x is equal to this. All right. So you can have this one also as a decimal if you want. You can separate them. Minus 1 plus square root I square root of 3. Another one minus 1 minus I square root of 3. So you've got 3 solutions at the end of the day. There are 3 solutions that you are seeing there. All right, so it can be like that. Yeah, that was why it was 6 marks. I was actually taking it for granted. But that is it. Under exam, guys, you just need to expect such things under your exam. All right, 2.5, 2 marks. All right, simplify this All right, these j, guys, the j to the exponent of this, all you just need to understand is that j squared, we know that it is -1. If j represents the square root of -1, then j squared is what? Is -1. So if we know this, it will be easier for us to simplify because all we need is to rewrite them in form of what? In form of j squared. So that was it, 2.5 j to the exponent of 5 minus j to the exponent of 27. Let us start exponent of 5 in terms of 2. 5 can be separated as j squared times j squared times j. But this j squared times j squared, guys, we can just write as j squared squared. It's one and the same. It's just like x squared times x squared. I can just write this as x squared squared. I haven't changed anything. I haven't changed anything. All right, so that's j squared times what? This j cannot be written as a j squared, so it just remained as it is. All right, so that was going to give us j squared squared times what? Times a j minus to the exponent of 27. We can target 26. 26 is an even number. So we can write as j squared to the exponent of what? Divide by 2 is going to give us 13. So it will be to the exponent of 13. So this can be written as j squared to the exponent of 13. Remember, we are focusing with 26. So there is a j that is left to give us what? A 27. So it's j to the exponent of 26 times j to give us 27. Then j to the exponent of 26 is this one. So there is also a j that is remaining there. Why targeting j squared? Because we said it is equal to -1. So where you see the j squared, substitute with a -1. So this is -1 squared times a j minus j squared and -1 again to the exponent of 13 times what? A j. This one. So negative when raised to the exponent of even number, it changes to a positive. So this is 1. You can even use your calculator, guys. -1 to the power of 2. This is going to give us a 1. So it's 1 times j, which is what? Which is a j. Minus -1 to the exponent of 13. This is not an even number. So it remains as a negative. So it was going to be -1 times j, which is -j. So what can we do here? These are simply like terms. J and j, they're like terms. These ones were not like terms because of what? Different powers. Yes, there's a j, but they're different what? Powers. Here, same powers to the power of 1. So these are called like terms. They can be added together or subtracted. So we can add, it's just like 1j plus 1j. You add 1 plus 1, which is what? Which is 2. So this is going to give us 2j or j2. Just like that. You can add them. They are now like terms. But previously, we could not subtract because they are not like terms because of different what? Powers. Powers are different. Yes, there's a j, but the moment the powers are different, you cannot what? You cannot simplify that. You cannot add. You cannot subtract that part. It is just like x cubed plus x to the exponent of 5. They cannot be added together. Cannot. You cannot add. All right, so that is it. There's so many ways, guys. Some they do factorizations, simplify. Guys, I cannot go through all that, but like I said, we have the comment section and we also have the community section. Utilize those if you need any other explanation, or you have another way that you could have answered, just take a picture. You've done answering your question. You can see that even if the answers are the same, take a picture and send it there. It can assist another learner. Don't be stingy to your information. Bring it to your platform so that anyone can learn. Question number 3. This is the trigonometry, everything, 20 marks, all right? Let us see what you're given. 3.1. Simplify as far as possible. Meaning to say you must simplify until you do not have any other way of simplifying. You are done in simplest form. In simplest form. All right. So there is tan of this and that. All right. So they are negative angles. They're also positive angles. So remember, I introduced both guys for positive angles. We know if we are using X, this is the first quadrant where we gonna have X as our acute angle, and here it will be 180 degrees minus X. Here it's 180 degrees plus X. Here is 360 degrees minus X, where we can use our cast concept for positive what? For positive angles. We also referred to negative angles, guys, if you still remember when I was saying the last this fourth quadrant is going to be negative X, and this will be X minus 180. This is minus X minus 180. This is X minus 360 degrees. These are negative angles. The quadrants still representing the cast concept, but they are negative what? They are negative angles. So if we check the first one, I'm just going to write the answer here, guys. Tan X minus 180. What type of an angle is that? It's a negative angle. Tan 180 minus what? Minus X. I mean X minus 180. Sorry for that, guys. The way that I'm saying something else while it's here is written something. It's X minus 180. X minus 180. It's under negative angles. We don't have something like that on positive angles. It's under negative angles. And it lies in the third quadrant, which is the quadrant for what? For tan. Tan is positive there. It is the quadrant for tan. So it means tan was going to remain as a positive. All right? We have a plus to separate. That's not a product. It's a plus. So you must use that sign. Plus sine of 180 degrees plus X. What type of an angle is 180 plus X? It's a positive angle. It's under positive angles here, 180 plus X. And it lies in the third quadrant, which is not for sine. Which is not for sine. Sine is found in the second, but here where there is 180 plus X, we are in the third quadrant for tan. So it means sine is what there? Is negative. So this was going to give us negative sine X. Sine is going to carry a negative there. The quadrant where 180 degrees plus X is found is not for sine. Times, there's a product here, the cos of minus X. Cos of minus X is a negative angle. As you can see, this is where we have minus X. And it is in the quadrant of cos. In the fourth quadrant, it's for cos. So cos is what there? Cos is positive. So it is just going to remain as cos of X. Where it lies, it is the quadrant for cos. And we are dealing with the cos. So cos is what? Positive there. All right. So let us move on to another one. There we are given a square. That is whatever that you are given, you must square it. All right. So you are going to square the answer, but we are going to focus with this sine 360 degrees minus X. 360 degrees minus x is a positive angle. It's under positive angles. And it lies in the fourth quadrant for cos, not for sine. It is for cos. So meaning to say, sine is a negative in the fourth quadrant. So it was going to be negative sine of what? Of x. But take note, it is being what? It is being squared. Whatever that you're going to have here must be squared. That is what it means. All right, so from there, guys, you can simplify. All right, so the question here is, what can we do? What can we do? There's a tan. I can change that tan into sine. Remember that tan of x is sine x over cos. So I can have it as sine of x over cos of x, all right? Plus and a minus is going to give us what? A negative. Remember, this is a product. So it's going to give us negative sine x times what? Times cos of x. Everything over what? Minus, when being squared, becomes a positive. So sine is just going to be sine squared. Sine squared of x, being a positive, minus was squared. So it becomes what? A positive. So this is where we are. And what can we do here? Guys, to simplify from here, there are so many ways. I'm not going to limit you to my calculation or my working. You can simplify the way that you understand, but at the end, you must have same answers here. All right. As for me, I was just going to take advantage of this sine of x in the what? In the numerator. I'm just going to factor it out. Or you can simply combine them as they are. But as for me, I'm just going to factor this sine of x since it is common in the denominator as it is. I can factor this one out. So if I factor out sine x, I'm going to remain with what? I remove sine x, is going to be 1 over cos. So I'm going to remain with 1 over cos of x minus. I remove this sine of x, I'm going to remain with what? Cos x. That is to factor out sine x. Everything over what? Sine squared of x. So here, guys, this is a product. I can simply cancel this. This is a product here. This one times this one. So it means I can even treat these two separately. I can divide those two. Sine x into sine x, that's 1. Into sine squared, that's sine x. So I'm remaining here with what? 1 over cos x in the numerator, 1 over cos x minus the cos of what? X, which I can combine to a single fraction, but this is the same as over 1. So I can simply have my denominator cos x, cos and cos, that's 1 times 1, which is 1, minus cos divided by 1, it's going to be cos x, then you multiply to cos, so it's going to be cos squared of x. So this whole part was going to give us 1 minus cos squared of x over what? Over sine x. This is where we are. All right, there is something that is common or in relation here. Remember that 1 minus sine. All right, did I put everything here? All right, guys, I left something here. I can see that I left something. It is over cos x, the denominator here. I'm supposed to take this whole part as it is. 1 minus cos squared of x over cos x. This is what we obtained from this one. But this whole part is going to be over what? This one. Sine of x. All right, over sine of x. All right, so yeah, this is it. I have referred to such type of fractions before, where you have a fraction over a certain term, a over b over c. I said, guys, this is, you just multiply the denominators, so it's a over b c. So in our case, you just multiply the denominators, cos and what? Cos and sine. So it means we're going to remain with the numerator 1 minus cos squared of x over, just multiply the denominators, cos and sine. So it's going to be cos x times what? Sine of x. That is it. 1 minus cos squared has got something in common from our Pythagorean identities. Do we have that in our formula sheet? Yes, yeah. Sine squared plus cos squared. But in our case, if you check, it is what? 1 minus cos squared. So what happened to obtain 1 minus cos squared? We took the cos squared to the other side. So we remained with what? Sine squared of x, and it was 1 minus cos squared of x. So meaning to say, in place of 1 minus cos squared, I can substitute with what? Sine squared. Just like that. So let us put sine squared in place of what? 1 minus cos squared. So it's going to be sine squared of x over what? Our denominator, cos x sine x as it is. All right, so here there's something common, a sine and a sine. So this one into these two, we are going to remain with the sine of x. So it's going to be sine of x over cos of x. This one that is remaining in the denominator. And we know that sine over cos represents what? Represents a tan. So the answer was just going to simply tan of x. All right, so you can obtain this same answer, guys, by using different ways in terms of the simplification thereafter. Do not be limited to my calculation, but you can even try another way that you understand. You are going to have what? We are going to have same answers at the end. Where you do not understand, let us communicate. All right, so that was 3.1. Let us move on to 3.2, where we had to solve that equation in within this interval that we are given. Solve what? The given trigonometric equation of 3 cos squared of x plus 11 sine of x plus 1 is equal to 0. All right, so in within from minus 360 up to 360. All right, do not worry about that. You can use the general solutions, then you can simply find all the possible solutions from there. But first things first, cos, this is sine. These two, it is just like you have got x squared and there's a y. There's no way you can solve that. You must have same terms. So if it is cos, let it be cos. If it is y, if it is sine, let it be sine. So which one can we change? Sine is difficult, guys, because it is not squared, but cos is being squared. Remember, from the previous question that we just said, we said cos squared is same as what? 1 minus sine squared of x. From that, cos squared x plus sine squared of x is equal to 1. So meaning to say, where I have a cos squared, I can simply substitute with what? 1 minus sine squared. So we had to get rid of the cos squared, this one, of the cos, so that we have it in terms of a sine, right? So that is going to give us 3 into this cos squared, which is same as what? 1 minus sine squared. So we're going to have 1 minus the sine squared of x. So this is it. The rest remains as it is, plus 11. Sine of x plus 1 is equal to 0. 3, expand here, 3 times 1, that's 3, times 3 here, minus 3. Sine squared of x plus 11, sine of x plus 1 is equal to 0. So as you can see, we have got a quadratic equation. Under our trigonometry, we have got a quadratic. So do not forget the format: ax squared plus bx plus c is equal to 0. So we're gonna have to express in that manner, starting with the squared. So I'm gonna start with this. This is our part where the sine is being squared. So that's negative 3 sine squared of x, followed by x, which is what? The sine of x, plus 11 sine of x. Then adding the numbers 3 and 1 is going to give us what? A 4. And that's equal to 0. All right, we can simply use our factorization, use quadratic formula. It's in your hands. All right, but just get rid of this negative on the first term there. Just divide by -1. 3 is not common. It is not a common factor, so just divide by what? A negative, so that it becomes a positive. We only just need that one to be a positive. 11 positive to negative, that's negative. Positive to negative, that's what? A negative, and that's equal to 0. At least we can work with this, apply our quadratic formula. We can use factorization. It is in your hands. Remember, if we say x is equal to, this time is what? Sine of x. So sine of x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. All right, so you can use or apply this or use your factorization. So meaning to say the sine of x is equal to minus, this is a, b, c. So minus 11 representing our b, plus or minus the square root of b squared minus 11 squared minus 4 times a, which is 3, times c, which is -4. Everything over 2a. Our a is what? 3. All right, so this is it. So you're gonna have the values here from your quadratic formula concept. Like I say, guys, always try to simplify what is under the square root first. Minus minus, that's a positive. Plus or minus the square root of, let us simplify what is just under the square root. Minus 11 squared minus 4 times 3 times -4 is going to give us 169. Everything over 2 times 3, which is 6. So you're going to have two possible values of our sine. Sine x is equal to what? Let us have a fraction. 11 plus the square root of 169 over what? 6. This is going to give us a 4. Or the sine of x is equal to, let us put a negative this time here. That is going to give us negative a third, -1 over 3. So that's -1 over 3. All right, remember we have to solve for x, guys. We have to solve for what? We have to solve for x. And this is a trigonometric equation. Sine cannot be greater than 1. Whenever we are to solve our trigonometric equation, I say that the sine of x, when it is equal to a is a number that is greater than or equal to -1, less than or equal to 1. It cannot be out of that interval or out of this range that you're given. So here, sine of x is equal to 4. It is no longer applicable. There is no solution that you can have there. It is out of what? Out of interval. Yes, you can even try to use your calculator. Remember, you're going to need to find the reference angle. Then you just apply arcsine of what? Arcsine of 4. The calculator is not going to produce anything. So you know that there is no solution from that one. So we are going to focus with this one. Let us find our reference angle. So reference angle is equal to what? Arcsine of 1 over 3. I told you guys, just ignore that negative, all right? Ignore the negative. So arcsine, that's shift sign here, shift sign, arcsine of what? 1 over 3. Ignore that negative. It's not important on the reference angle. So let me just also use 3 decimal place concept. So it's 19,471. So this is our reference angle, guys. This is our reference angle. And what we need here are the exact solutions. So what you can do, guys, is that since the interval is too big, guys, from -360, from -360 up to 360, this interval is big. If it was from 0 to 360, you can simply use your quadrants. Since you have got your reference angle, you can use these quadrants because you know that where sine is what? Negative from our cast concept. all right, from our cast concept, where sine is what? Is a negative. It is in the third and in the fourth quadrant. So you know that your solutions will be in the third and fourth. But there are also negative values from there. So I was just going to advise you to have it from general solutions. It'll be easier if you've got your general solutions. For the general solutions, we know that, all right, x is equal to, for a sine, if we are dealing with a sine, if we are dealing with sine, remember we are taking where it is negative. So it is negative in the third and in the fourth quadrant, all right? So it is, that is where it is negative. So here it's going to be 180 degrees plus x. Remember this, all right? Let us refer to the reference angle. This is 180 degrees minus reference angle. 180 plus reference angle. 360 minus our reference angle. So we are going to focus with what? The third and fourth quadrant, where our sign is what? Is negative. So the first general solution, x is equal to, we are supposed to have 180 degrees plus a reference angle. So it's 180 degrees plus our reference angle 19,471 plus 360 degrees times what? Times k. So if you were to simplify this, that is going to give us what? 199. 199,471 degrees plus 360 times k. So this is the first general solution. Then the second one, where sine is negative, remember it was a negative, here sine x is minus. So it is the fourth quadrant, 360 minus reference angle. So x is equal to 360 degrees minus what? The reference angle. So it was supposed to be 360 degrees minus the reference angle, 19,471. All right. You subtract the reference angle plus 360 times what? 360 times k. So that's our x. And from here, it was going to give us 340,529 plus 360 times k. All right. So this is the second general solution, where we understand that k is supposed to be representing what? An integer. So k is any integer value. That is the concept. All right. K is an integer. So these are our general solutions, guys. The first one and this second one. But the question here was not about the general solution, because when you're given an interval like this, solve, and you're given an interval from this to this, they want you to find exact values. Solve for x direct. It's not about general solution. We are given an interval to apply. So you test now the values of k, because k is an integer. That's an integer value. So you test your integer values. All right. Since we are having values from minus 360 to 360, we can use negative values. So let's start with negative 2. Negative 2 is going to be out of range, guys, because it will be minus 360. It's going to be 720 some, negative 720 something. This is going to be totally out of range. But let me put this one, what I'm trying to say. When k is minus 2, you put it this way. When k is minus 2, it's 199,471 plus 360. You open bracket. In place of k, you put what? Negative 2. Let's see what you're going to have. It's minus 540 something. It's out of the interval. Out of the interval. Remember, our values are to be taken from where? Our values are to be taken from minus 360 to 360. It's out of the interval. We cannot use it. So k, when k is minus 2, there's no solution. All right, there's no solution. Let us move on to minus 1. When k is minus 1, we put minus 1 here in place of k. That is what? Minus 160,529. It is within this interval, this number. So it is part of our x. So x can be equal to minus 160,529. All right, let us move on to 0. It's an integer again. So when k is 0, substitute 0 here in place of k. You put a 0. That's 199,471. It is also in within the interval. So x can be equal to 199,471. It is in within the interval. Where k is equal to 2, we can see to be 728. This one is going to be out of the interval. You can try, but you can see that it'll be out. So for this first general solution, these are the two solutions that we obtained. We move on to the second general solution. We do the same. Substitute these integers just like before. So let's start with minus 2, but we can see it's out of interval. Let's see, 340,529 plus 360 times our k being what? Negative 2. Our k being negative 2, like this. All right, it's going to give us negative 379, it's out of the interval from minus 360. It's not found in within that. So we move on to minus 1. The first one failed. So let us move on to minus 1. We put minus 1 here. So this is going to give us negative 19,4. It is in within this interval. So x can be equal to negative 19,471 degrees. Let us move on. When k is 0, we put a 0 here. In place of k, we're going to put a 0. And we're going to have 340.529. It is also in within. It is less than 360. 340 is less than 360. So it is in within our interval. So we need this solution. X can be equal to 340,529. So these are the possible solution. When k is 2, guys, it's going to be out of, because it's already 720. It's out of the interval. So these are the possible solutions that we're going to have. So therefore, x is equal to what? I can start with these negative values, negative 160,529, or it can be equal to negative 19,471 degrees, or it can be equal to 199,471, or it can be equal to what? This one, 340,529. For the given interval from minus 360 to 360, because we have an interval. So these are the only possible values that we can obtain from that given interval. These are the only ones. These are the only ones that you can ever get. All right. So that is it. If you are to work from your general solutions, it is important to know general solutions, because sometimes they will just ask you to determine just only the general solution. So it is something that you cannot run away from. It is part of your syllabus. So learn also to apply that if you can understand. That is good. All right. Derive this formula. That is cos x over 2. If this is equal to if it is from that, derive it from here. Derive it from cos 2x, as we see, which is equal to 2 cos squared x minus 1. Derive it from there. Find what exactly represents cos x over 2. Okay. The cos x can be found, we are talking about cos x, not x over 2, but just x, can be found from cos squared. It is It is where we have x. This is 2x, not x, but x is on cos squared. So let us play around that cos squared here. This is where we can have cos x, and we can make adjustments from that cos of x. So what is it that we can get rid from that so that we make that one the subject of the formula? All right. There is this one which is not important. Let's take it to the other side of the equation. So it's going to be 1 plus cos 2x, or cos 2x plus 1. All right, or cos 2x plus 1. One and the same, all right? And this is equal to what? 2 cos squared of x. Remember, we are targeting to find cos x. So let's get rid of this 2 under a product, divide by what? By 2. So meaning to say cos squared of x is equal to this. 1 plus cos 2x over what? Over 2. If cos squared is equal to this, what about cos x? Because it will be easier to find cos 2x if we have cos x. If we have this cos x, what is affecting? That's the square. Get rid of that. Introduce the square root. All right. So the square root and this cancels. So cos of x is equal to the square root of this, which we know that the square root of any number is what? Plus or minus. 1 plus cos 2x over what? Over 2. All right. So here, guys, when you're under trigonometry, let's say you are given that cos squared x is equal to 1 minus sine squared of x. If there is x here and you choose that you are going to divide by 2, you must also divide here by 2, the part of x. If you choose to multiply the left-hand side by 2 here, also multiply here by 2. If you choose to multiply by 4, also do that. On the angle, this is x. This is our angle, 2x. So here we are going to divide, because what we need is cos x over 2, but we have cos x. But what you do on the left-hand side must be done also on the right-hand side. On the trig, it only affects the trig. One is it was not affected. So the moment I choose to divide this one by 2, cos x over 2, I am supposed to do the same thing where I have a trig on the right hand side, and we have a trig here which is cos 2x. So I'm going to divide 1 plus cos 2x over 2 in that part of the angle part. You must divide it by 2 the same way that you did here. If you do that, it remains the same. You haven't affected your question, you haven't affected anything. So that's how we treat our trigonometric equations. What you do on the left hand side must be done on the right hand side. So therefore, the cos of x over 2 is equal to plus or minus the square root of what? I'm going to simplify here. 2 and 2, that is going to cancel. So it will be 1 plus cos x over what? Over 2. This is what you're going to have at the end. So we have derived this half angle for a cos 2x, that it is equal to this. Just like that. Just like that. All right. Moving on to the other question. Now they're saying, use the formula derived in question 3.31, the one that you just derived now, to determine the exact value of cos 15 without using a calculator. Now you must what? Determine the exact value of cos 15 from this formula that you just derived. They are saying find cos 15 from this formula that you just derived. What is going to be the value of cos 15 degrees? All right? Our formula is stating that the cos of x over 2, take note, x, 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 x. This is also x. This is x over 2. So it means, let's say I have 50 degrees. Let's say I have 50 degrees here. How is it going to be written here? It's going to be 50 degrees over 2, which is 25 degrees. This is going to be 25 degrees. So are we seeing that this is half of what we are having there? It is half of that. So meaning to say, if I am given cos of 10, if if the whole of this part here is 10 degrees, it means this whole part is 20 degrees multiplied by 2, because here it is x over 2. 20 over 2 gives us what? A 10. So when you are given now to find cos 15, as we have in our main here, cos 15, 15 simply means 30 degrees over 2, because it is half. This one is a half angle. It is 30 over 2. 30 over 2 to obtain this 15. So our x is equal to what? Our x is equal to 30, which is the same that we need here. So we're going to put x, which is what? 30 there. So this is it. 1 plus cos of 30. If this is 15, multiply by 2. If this is 20, multiply by 2. If this is 60, multiply by 2. So 15 times 2 is what? Is 30. So that's cos 30 over what? Over 2, like that. Everything over 2, I mean. So this is cos 15. It can be written in this manner. Cos 15, we cannot simplify it direct. But cos 30, we know it because it is what? From our special angles. All right, remember your special angles, which I said actually there's nothing special about that, because you can know them, those ones, by head. So just put your special angles. Remember, if this is 30, this is 60, this is 1, 2, square root of 3. And we are referring to cos adjacent over hypotenuse. So cos 30 is square root of 3 over what? Over 2, which is exactly the same thing that you can obtain from your calculator. Cos 30. No one is going to know that you have used a calculator there. Use it. Square root of 3 over what? Over 2. That is the value of cos 30. So it's going to be plus or minus the square root of 1 plus cos 30 square root of 3 over 2. Everything over 2. So what I can do here is to simplify or evaluate the numerator separately. 1 plus square root of 3 over 2. This is over 1. So LCM is going to be 2. 2 divided by 1 is 2 times 1. That's a 2 plus 2 divided by 2, that's 1 times square root of 3. So it's going to be square root of 3. So meaning to say here, I'm going to obtain 2 plus square root of 3 over what? Over 2. But everything is over this 2 here. Remember, here we're just simplifying what? The numerator. We're just evaluating the numerator. So the denominator is just left as it is, as a 2. So we are just going to have our 2 here. Are we seeing that we are back to those fractions that I've been talking about, guys, where there's a fraction and there's another fraction, A over B, C concept? A over B over C. Remember, I told you it's going to give us A over what? You multiply B and C. So meaning to say, you simply maintain the numerator, but multiply what? The denominators. So in our case, this is our numerator. We are going to maintain it and multiply the denominators, just like that. So this is going to give us plus or minus the square root of what? 2 plus the square root of 3. Then multiply the denominators together. 2 times what? 2 times 2, which is 4. So it is over 4. Using this A, B, C concept. All right. So here we have got 2 terms, one in the numerator, in the denominator. But we can separate. Remember, square root of A over B is the same as square root of A over square root of B. So we can separate them, the numerator on its own. So it simply means it was going to be plus or minus the square root of what is in the numerator. The square root of what? In the numerator, it is 2 plus square root of 3 over what? The denominator, square root of 4. And what is square root of 4? It is 2. So it's going to be over 2 like this. All right, so this is what you're going to get at the end in simplest form. You can leave your answer like this. There's no other way that we can simplify further. Just leave it like that. So that is it. These are half angles. Go through the videos under trigonometry. I have explained about all this so that you can understand much better on these simplifications. All right, you can understand much better. So that was it. Yes, that was it here on question 3.22, which is the last part actually that we are having of question 3. All right, this is the last part of our question 3. This is the last part, as we can see. 6 marks for that, and the whole part of our question 3, 20 marks. So they can ask questions like that. All you just need is to be very careful how to answer your questions. All right, you need to know all the basics in your syllabus. So we're not gonna waste our time. Let us consider question 4. There we are given to differentiate on 4.1. Differentiate this from or using first principles. All right, so the first principles, guys, is one of the easiest because you just need to follow up the formula as it is. All right, 4.1. To differentiate y, to differentiate y with respect to x, we are saying this is a function of x. Y is equal to this. It's a function of x. So its derivative, f prime, or you can write dy dx, is equal to the limit as h approaches to 0 of f of x plus h minus f of x, everything over h. So I want you guys to learn to simplify this whole part in the numerator. Learn to separate that part, work on its own separately. So our f of x is the original function that we are given. Y is equal to that. That's your f of x, which is equal to 2x cubed minus 4. But we are going to need f of x plus h, where f of x plus h simply means substitute x plus h in place of what? In place of x. So it was going to be 2 into x plus h cubed minus 4. Guys, remember this expansion to the exponent of 3. We dealt with this one. So if you understand, a plus b cubed, which is equal to a cubed, all right, plus 3a squared b plus 3ab squared plus b cubed. Yes, you can expand that, or if you do not understand, you have two brackets, x plus h squared. You expand this, then you multiply by x plus h. So it was going to be x cubed plus 3x squared h plus 3x h squared. So this one reduces cubed from 3 to now it's 1, and this will be increasing h, so it's going to be h squared up to a condition where we have got h cubed. All right, then there's a negative 4. Do not forget that negative 4. So expand brackets, then simplify. 2 has to expand every term, so this is 2x cubed. 2 times 3, that's 6 x squared h. 2 and 3, that's going to give us 6x h squared to the last one. 2 and h cubed is going to be 2h cubed minus 4. All right, we do not have any like terms, so we have our f of x plus h in simplest form. But like I said, let us just simplify everything. Find f of x plus h minus f of x. So meaning to say we're going to take this as it is, 2x cubed plus 6x squared h, 6x h squared plus 2h cubed minus 4. Then we are going to subtract our f of x, and this is our f of x. We're going to subtract it, 2x cubed minus 4, just like that. So meaning to say that was going to be, yes, just a repetition. Just repeat all this part as it is. All right. Then multiplying by negative times 2 is going to be negative 2x cubed. Negative times negative 4, that will be a positive. Negative, that's a positive 4. And collect your like terms. Thus, we are given, we have got 2x cubed here, 2x cubed and 2x cubed. That's going to cancel. Minus 4 plus 4, these two also cancel. So meaning to say, this is what we are going to remain with as the difference between f of x plus h minus what? Minus f of x. This is what you're going to remain with, and that's equal to 6x squared h plus 6x h squared plus 2h cubed. All right, plus 2. Where did I get? Right, so this is it. Yes, that is what you gonna have at the end. All right, so now let us substitute into our formula this whole part that we have here. I want us to see the magic that is gonna happen here if you substitute back to our first principles formula. The first derivative will equal to the limit as h approaches to 0 of this part that we obtained, 6x squared h plus 6x h squared plus 2h cubed. everything over h, the denominator still as it is over h. So this is what you're going to have at the end. And we can evaluate h is common in the numerator. There is h, there is h, there is h. So we can factor that h out. We can factor our h in the numerator. So it's going to be h. If we factor out, you're going to remain with 6x squared. Here, if we factor out h, it's going to be 6xh. We'll remain with 1h there. So it will be 6xh. And this will be 2h squared. Everything over h in the denominator, so that you can simply cancel these two. And this is what you are remaining with. We no longer have the h in the denominator, so the limits where h approaches to 0 can be used. All right, 6x squared plus 6xh plus 2h squared. We are saying in place of h, now substitute a 0 wherever there is h. So if you put a 0 here, a 0 here, you are going to remain with what? 6x squared. That part is not going to be affected. So therefore, this is our derivative at the end of the day. That is going to give us what? 6x squared. All right? Just like that. So that is how these questions will be given. Just learn how to expand these separately. If you can just manage to do that, substitute into your formula and simplify further. All right. Then 4.2, it was to use the product rule. That was 5 marks for that. If you check, it is 5 marks. Use the product rule, all right? The product rule, where we are given, all right, let me try and have it aside. All right, so this is 4.2. Use the product rule. So if we were to consider what we are given, the product rule, we have it in our formula sheet, which is okay, but all right, let's just see what we can do here. 3x squared times pi to the exponent of x. We can see that these two are exactly a product. We have got two functions of x under a product. So we can let one of these to be u and the other one to be what? Our v. So that is what we can do. And according to your formula sheet, this is what we can apply as of our product rule. All right, it is in your hands. You can use that formula as it is. All right, so the derivative here from our product rule is gonna be u times the first derivative of v plus the first derivative of u and v. So meaning to say we're gonna need our u separately, 3x squared, and determine its derivative. Drop the power, multiply that, it's gonna be 6. We subtract 1, so it's 6x. When we are given pi to the exponent of x, that's our v, which is pi to the exponent of x. This derivative is the same. We have that one in our formula sheet. If you check under your derivatives, down, not under derivatives. All right, there they gave us for integration. There's one for derivatives. All right, this one, a to the exponent of x, ka to the exponent of x is going to be ka to the exponent of x ln of a. So as we can see, it is the same as that pi. So it's just going to be pi remains because it was pi to the exponent of x. So it is just like a to the exponent of x. So it's going to be pi to the exponent of x times the ln of a. A is the base, so it's ln of what? Ln of pi. So this is what you're going to have when you differentiate that one from that formula that you're given. So the first derivative, it's pi to the exponent of x times ln of what? Pi. Then use your formula. So therefore, dy dx is equal to what? The derivative of y with respect to x. We can simply apply our formula. So that's u, 3x squared times our first derivative of v. This is the first derivative of v, which is pi to the exponent of x ln of pi. Then we're going to need to add plus the first derivative of u, which is 6x times our v, and our v is what? Pi to the exponent of x. So this is the concept. You can expand here the way that you want. I'm just going to take 3 and ln together. So 3 ln of what? Ln of pi. Then I have this pi to the exponent of x times x squared. All right, I'm just going to take it like this. Plus this one, I'm just going to also have 6 pi to the exponent of x times what? Times x. All right, no matter the way that you want to present it, but that was going to be your final answer at the end. All right, there's no simplification. Don't bother factorizing this and that. We are done. So that is the product rule for 5 marks. All right, that was okay. 4.3, we are now given determine this limit. All right, y. That is y is equal to, here they made a mistake, it's supposed to be y is equal to this limit, the limit where x approaches to 3 of x squared minus 9 over 3x minus 9. All right, if you're to apply the limits, we can see that if we put a 3 right now here, if we put a 3, it's going to be 3 squared, which is 9 minus 9, that's a 0. 3 times 3, that's 9, minus 9, that's a 0, which is not allowed to have that 0 over 0 under your limits. So what you can do is to factorize. All right, in our syllabus, factorization, yes, derivatives can be used, but here it was just an issue of factorizing so that we avoid having 0 over 0. So it's going to be limit x approaches to 3. So let us what? Factorize. All right, the first one is a difference of 2 squares. So just apply your difference of 2 squares. Square root of x squared is x. Square root of 9 is 3. So one is going to subtract, another one is going to add. Over what? The denominator, 3 is common. We can factor out 3. So 3x divided by 3 is going to give us x. Minus 9 divided by 3 is going to give us negative 3. And we can see that there are common brackets in the numerator and the denominator, so we can get rid of those brackets, x minus 3, x minus 3. And that was going to remain or give us x plus 3 over what? Over 3. So this is what you're going to have at the end. After that factorization concept, apply the limits again and see if you're going to obtain 0 over 0 or not. So let's apply our limits again. In place of x, we're going to put a 3. So it's 3 plus 3, which is 6 over 3. And 6 over 3 is going to give us a 2. So as we can see, guys, that this limit can be simplified when x is equal to what? 3. And it's going to give us a 2. So meaning to say y is equal to 2. Remember, y is equal to this limit. So that's why it gives us what? A 2 from that limit that we are given. So that was the concept. You are done. You are going to obtain full marks, all the marks, 3 marks for that. All right. Then 4.4, you're asked to differentiate with respect to x, meaning to say we must differentiate properly with respect to x, where y is equal to. All right, let us simplify first that one. We have x to the exponent of -1 plus x. All right, plus x here plus x raised to the exponent of 2. Then we have got the square root of x, which is same as what? X to the exponent of a half. All right, let's expand the inner bracket first. As we can see, it is being squared. Everything is being what? Everything is being squared. Which concept can we use? Remember, a plus b squared is equal to a squared plus 2ab plus b squared. So you can use that concept, a plus b. So a is representing x minus 1, x to the exponent of -1, I mean. Our b represents this x. So from that simplification, we are saying that we are going to have a squared, a, but it is what? A squared. So we must square x to the exponent of -1. It must be squared. So remember, these two multiplies each other. So it's x to the exponent of -2 plus 2ab. So that's plus 2 times our a is what? X to the exponent of -1. Our b is what? Our b is x. So these two, when you simplify, remember you're multiplying same bases, you add the powers. So it was going to be x to the exponent of -1 plus 1, which is what? Which is a 0, this one. And any number to the power of 0, it's 1. So it was going to give us 2 times 1, which is 2. All right, then the last one is b squared. And our b is represented by what? By x. So x squared, guys, is just what? X squared. So we have expanded the inner bracket, this one, which was being raised to the exponent of 2. But after that, we can see that there is also this x to the exponent of x to the exponent of a half, which is yet to expand our bracket by multiplying each and every term by that. You multiply this to this one. So there is just issue of same bases. You add the powers. You're multiplying same bases, so you add powers. -2 plus a half. And that's -2 plus a half is -3/2. You can use your calculator there. -3/2. So that's x to the exponent of -3/2. We multiply that x to the exponent of half to 2. So it's going to be plus 2x to the exponent of a half. We multiply it to x squared. These are same bases. We add the powers. 2 plus a half, which is what? 5/2. So that was going to give us 5/2x to the exponent of 5/2. So we have expanded, guys. This was expansion, not differentiating. No. It was just expanding. Now we need to differentiate. So I'm going to take this y as it is. This is our y, this one. Sorry for that. All right, let me try and see if it's going to work. I'm going to just take this part of y. All right, why is it doing like this now, guys? And I just want this part, only this one. All right, it's failing. Let me just rewrite. So as we saw that y now is equal to x to the exponent of -3/2 plus 2x to the exponent of a half. All right, plus the last term, which was x to the exponent of 5/2. This is what we got after expanding everything. this. So now we can differentiate that. It is easier now when these terms are separated, as we can see this one on its own, this one on its own. So the derivative of y with respect to x is equal to what? Remember the concept, you drop the power, you subtract 1. So if you drop the power, that's minus 3 over 2x. Subtract 1. Minus 3 over 2 minus 1 is minus 5 over 2. All right? You do the same thing here. Drop the power. 2 times a half, that's a 1. So it was going to be plus 1, which is x. 1 times whatever that you have, guys. It's just going to remain like that. Then you subtract a 1 from there. So this is half minus 1. So half minus 1 is going to give us minus half. So that's x to the exponent of minus half. Okay, we move on. We have got x to the exponent of 5. We do the same thing. Drop the power, subtract 1. So that was going to be 5 over 2. 5 over 2 minus 1 is what? 3 over 2. Okay, so this is what we have. And if we are to consider, we are done differentiating only the simplification. If you want, there you can simplify each, taking or getting rid of these negative exponents. We know that a negative simply means 1 over. So it's going to be minus 3 over 2x to the exponent of 5 over 2. Here we're going to have, it's a negative, so it's 1 over x to the exponent of a half plus 5 over 2x to the exponent of 3 over 2. All right, this is a positive, this one, so there's no simplification that you can do. There's no 1 over there. As we have got get rid of our negative exponents, now we have got positive exponents, but these can also be written in simplest form. So it's minus 3 over 2, x to the exponent of 5 over 2. Remember, x to the exponent of a over b is equal to the bth root of x to the exponent of a. So here is going to be the square root of x to the exponent of 5 plus 1 over to the exponent of 5 means square root plus 5 over 2. This same concept, so it's going to be square root of x to the exponent of 3. So that is what you're going to have at the end if you are to apply your derivatives. All right, if you are to apply your derivatives in the simplest form, avoiding these rational exponents, avoiding negative exponents, that is your simplest answer that you can have. All right, let us consider another one, 5.4, 4.5, I mean. All right, on 4.5, let us see what we have on this one. So as we proceed to 4.5, there we are given a function of x, which we are asked to calculate using differentiation, the coordinates of the turning point and the points of inflection, and also distinguish between maximum and minimum turning points by using the second derivative. So it's like actually determining everything. All right, so this type of a question, guys, these are 7 marks for free in exam, because all you just need is to follow up the steps as usual. All right, we know that at the turning point, the first derivative must be equal to 0. So what we're going to need is to find the first derivative, just like that. Drop the power, subtract 1, 3x squared. Drop the power, 2 times 2, that's 4, so it's going to be 4x minus 8. Here we're just going to take the coefficient of x. So this is our first derivative, which we are saying at the turning point, it must be equal to 0. So what does this tell us? It means we are going to form an equation for that from that f of x. 3x squared minus 4x minus 8 must be equal to 0. That's a quadratic equation that you have formed. Solve that one. I'm just going to use quadratic formula because factorization most of the times here is not going to work. You have decimals, this and that. So using your quadratic formula, remember ax squared plus bx plus c must be equal to 0, which is our quadratic equation. So we've got a, b, and c. And the formula states that x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So that's in our case, x is equal to minus, our b is what? Negative 4 plus or minus the square root of b. Our b is what? Negative 4. So that's negative 4 squared minus 4 times a, which is 3 times c, which is negative 8. Everything over 2 times a, which is 3. So that was gonna give us the solution at the end. Minus here is gonna be a positive. So that's 4 plus or minus the square root of, I'm just gonna simplify this part under the square root. All right, I have negative, all right, let me put my calculator to normal mode. So I've got negative 4 squared minus 4 times 3 times negative 8, and that is going to give us 112. Everything over 2 times 3, which is 6, and from there we can have two possible solutions for x. 4 plus the square root of 112 over 6 is going to give us this one as a decimal 2,4. 31 to 3 decimal places, that is going to be 2,431, or x is equal to, I'm going to put a negative here. I'm going to have a negative, and that is going to give us negative 1,097, negative 1,097. All right, so these are the possible values of x, two possible values. So I'm just going to name them x1, x2, x1, x2. So meaning to say, to have the turning point, the first turning point for x1, which is 2,431, if we substitute this into the original equation, what are you going to have? You're going to put back into f of x your original equation, the one that you were given before. Remember, our f of x was y is equal to x cubed minus 2x squared minus 8x. So you're going to substitute the value of x, 2,431 in place of x. All right, then this is squared minus 8 times that 2,431. So that was going to give us negative 16,901 to 3 decimal places. All right, and the other turning point, second turning point when x is minus 1,097. Substitute that here in place of x, you're gonna get 5,049. So these are the two turning points. So the first question was to determine these turning points. All right, and we are going to need the point of inflection and to distinguish. So before we look into the point of inflection, let us distinguish our turning points. How do we distinguish our turning points before we look into the point of what? The point of inflection. In order for you to distinguish this, you are going to need the second derivative, all right? Remember, this is our first derivative here. So you're going to take from the first derivative, this one, all right? So I'm going to take that one. Remember that your first derivative, we need to distinguish here. All right. Remember, our first derivative was equal to 3x squared minus 4x minus 8. So it follows that for you to distinguish, you have to find the second derivative with respect to x. When the second derivative with respect to x is greater than 0, meaning to say when you obtain a positive, it is from a minimum turning point. But when the second derivative is less than 0, where we are talking about negative values, that one will be your maximum turning point. So just differentiate, guys. Find the second derivative. Multiply this, is going to be 6x minus what? Minus 4. This is a constant. It's going to give us a 0. So this is your second derivative. Find from the first turning point, the value of x is what? This. Substitute that one and see the value that you're going to obtain when you have got 2,431. Substitute it in place of x. 2,431 minus 4. That was going to give us... all right, let me just apply the calculator here. I forgot to present it on my presentation, but that is 2.431 minus 4, and that is going to give us this 10,586, which is what? A positive greater than 0. It is a positive value. Our second derivative with respect to x is a positive. So meaning to say, from that value of x that we took it, that point is what? A minimum turning point. When you get a positive, it means it was taken from a minimum turning point. So the first turning point is what? Minimum turning point. So you do the same for the second turning point, where x is minus 1,097. You substitute that in place of x in the second derivative. But as we can see, it's going to give us a negative value here. But anyways, just simplify that. 6 into minus 1.097 minus 4. That's negative 10,582. Negative 10,582. We are obtaining a negative value. A negative value, it means our second derivative is less than 0. So that's what? A maximum turning point. So the second turning point is what? A maximum turning point. So that is the case on your turning points. You just need to find the second derivative and compare it that way. So let us move on to the last part, which is the point of inflection. As of the point of inflection, it follows that the second derivative must be equal to 0 for that. And already you have got that second derivative. So simply solve this must be equal to 0. So 6x is equal to 4. Solve for x. So x is going to be 4 over 6, which is 2 over 3. This is the value of x at the point of inflection. So to find the value of y, you're going to substitute back into the original equation in place of what? In place of x, just like before, you're going to substitute 2 over 3. By doing that, you're going to obtain the value of y as minus 160 over 27. So therefore, it means that our point of inflection is going to be x is 2 over 3 and y is minus 160 over 27. So this is what you're supposed to have. Please make sure that you substitute those values properly into what? Into the given original function that you had before, your f of x. All right, so that was it. Like I said, it's 7 marks for free, this one in exam, because it's just issue of following up. You follow up just like that. This is how you answer this type of a question. Let us move on to another part, which is actually the last part of our question number 5. Integration, the first one with 8 marks. We're being asked to integrate the whole of this part. All right, let's see. Remember, integration, when it is like this, you must integrate each and every part. So let us start with this one. I'm just going to write the answer, guys. All right, 5.1, I'm just going to write the answer. So from our integration, remember I referred back this one. In your formula sheet, it's not properly given. So let me write it in this way. The integral of k a to the exponent of f of x with respect to x is going to give us k a to the exponent of f of x over first derivative of x ln of a. All right, so in our case, we have got this part here, which is our k is what? Is 4. So it was going to give us 4 times a to the exponent of x, as it is 5 to the exponent of 3x over what? The first derivative of x. If you differentiate your f of x, if you differentiate 3x, you are going to obtain what? A 3 times the ln of a, the base on our exponent there, on this base 5 to the exponent of. Our base is what? Is 5. So it's going to be ln of 5. We have integrated that. Let's integrate a cos. Remember, cos, if you integrate it, that's the reverse of here. If you integrate a cos, it's going to give us a sine. All right, the opposite of differentiation, or you can check here on these integrals where you're given cos is going to give us what? Sine. So meaning say that's a positive. But take note of this 4 that you're given. It was supposed to be 4 sine 4x, but under integration we divide. So you're going to divide by this 4, the coefficient of x on that. So you divide by that. So as we can see, the 4 and the 4 was going to cancel, and you remain with what? Sine of 4x. So it was plus sine of 4x. We have integrated that part. Sec squared, sec, if you check, it is the opposite from our integration here. I mean, from our derivative. When you differentiate tan, you get sec. So the opposite, if you integrate sec, you're going to obtain what? A tan. So the integral of sec squared is going to give us a tan. So that was going to be plus 7 tan x. All right. Minus pi over 2x. This is minus pi over 2 is a constant. So you're going to take it as it is. Then the integral of 1 over x with respect to x, we know that's a ln. So it's going to be ln of x. Also, you have it from your formula sheet. Then sine 6x. The integral of a sine gives us a negative cos. All right, if you integrate a sine, you get a negative cos. So you must have a negative there. So it was supposed to be negative cos 6x, but we must divide by the coefficient, which is what? Which is 6. So that was it. No simplification. So just rewrite as it is, minus cos 6x over 6. We have integrated that. Then here to integrate, let us first rewrite properly. Minus 2 over 3. The square root of x cubed means what? X to the exponent of 3 over 2. So when you integrate, remember the concept, you must add the power, then divide by the new power. So if you add 1 on the power, that was going to be 5 over 2. So it was going to be like this. When you integrate this, it was going to be minus 2 over 3 times. You add 1 on the power, so it's x to the exponent. It's going to be 5 over 2. But you must divide by that new exponent, the new power, 5 over 2 here. So this is it. Minus 2 over 3. 1 over 5 over 2, guys, is going to give us 2 over 5. All right, x to the exponent of 5 over 2. So if you multiply the numerator to the numerator, that's negative 4 over what? Denominator to denominator, that's 15. X to the exponent of 5 over 2, which you can write as the square root. This one is going to be the square root of x to the exponent of 5. You can have it in simplest form like that, or you can just leave it like that. It's not a problem. All right, so that was it. We have integrated. Then we move on to minus half cosec. All right, minus half cosec 2x minus half cosec 2x. Oh, sorry, it's cosec 2x cot 2x. Cot 2x, all right? So how do we integrate this cosec cot from our integrals where we have cosec and cot we do not have under these, so you're going to use derivatives where we have got cosec. We differentiated cosec and obtained minus cosec cot. So integration is the reverse. If you integrate this, we are going to obtain this. If you integrate a negative, it will give you a positive. If you integrate it as a positive, it will give you a negative. So I'm just going to take the whole of this part with a negative. So it means we're going to obtain what? Cosec x. If we integrate that, it is going to give us a positive cosec x. So I'm going to take with this negative. So negative, I'm going to use this. So it's going to give us positive 1 over 2 cosec x. And our cosec is what? Let me have it here because this one. So you said 1 over 2 cosec. Our x is not, it's 2x. So it's cosec 2x. Remember, it's integration. You must divide by the coefficient of what? The trig. So over 2. So these two can be simplified. 1 over 2 divided by 2 is what? 1 over 4. So that's 1 over 4 cosec 2x. All right, just like that. Then integration, remember to add the constant of integration at the end. So that was it here, to just integrate each part separately. You rewrite and integrate. This is what you're going to have. All right, let us move on. 5.21. We're given this sketch. All right, sketch this and show the area of the strip enclosed by that graph. And all right, so this is a cubic function, guys. A cubic function. And yeah, remember, on a cubic function, ax cubed plus bx squared plus cx plus d. A represents the shape. When a is greater than 0, you're going to have something like this. So we know our shape, how it is going to look like. All right. All right. Sorry for that. So you're going to have you're going to need the sketch, the first shape first. All right. So once we've got our shape here, let us now determine the x-intercepts. All right. Gonna need the intercepts with x's. Those are the only important things. The rest, do not worry, guys, because it's just 3 marks at the end of the day. So let us find our x-intercepts. As we can see that the y-intercept is at 0. It's at the origin. When x is equal to 0, y is what? Y is 0. So to find your solutions for x, y must be equal to 0 in order for us to have the x-intercepts. So that's 2x cubed minus 2x is equal to 0. We're going to solve this equation. 2x is common between these two, so it's 2x. 2x cubed divided by 2x, that was going to give us x squared, minus 2x divided by 2x, that's a negative 1, and that's equal to 0. Remember the 0 product, each must be equal to 0, so 2x must be equal to 0, or x squared minus 1 must be equal to 0. So here, if we divide by 2, it simply means x is equal to 0, or x squared is equal to 1. Then we're going to need the square root of both sides, which is plus or minus 1. Remember that the square root of any number is what? Plus or minus. So that was going to be plus or minus what? 1. We need to say there are two solutions. There are two solutions that we have. So with the sketch, the shape that you already have here, you can tell how this graph was going to look like, because it's going to pass through -1, 0, and 1. So that's something like this according to the shape that we have there, and it passes through 1. So this is -1, this is 0, and this is 1, our x-intercepts. And you can see that the y-intercept is on the origin. So that was it. This is our function, or the graph of y is equal to 2x cubed minus 2x. So it was just like that. And from there, you are being asked to, they said you must show the strip enclosed by this, the x-axis, all right, which lies in the second quadrant. So they are focusing about the second quadrant. And this is our second quadrant. So the area that we need is the one here bounded by the graph and what? The x-axis. So this is the region that we need our area in the second quadrant. So I'm just going to show the strip as we have got the limits for x. And that's it. So this is where you're going to calculate your area. So that was the sketch, guys, just like that. All right, 5.2 to calculate the indicated, the area indicated in question 5.1 by means of what? Integration. Remember, they told us the area is supposed to be taken what? In the second quadrant. So you're going to just focus with the second quadrant here, remembering that area is simply the integral. All right, so area with respect to x is simply going to integrate y with respect to x. That is f of x. Taken our limits from a to b. So that's our ax is the integral. Y is equal to what? This 2x cubed minus 2x. So you integrate this with respect to x. Our limits in the second quadrant, it's from -1 up to 0. Here in the second quadrant only. So -1, our lower limit, 0, our upper limit. Just like that. So that is it. Integrate that, you are done. Apply the limits. So as you integrate, it's going to be, remember integration, you must add 1. So it was going to be 2x to the exponent of 4 over 4. And that's 1 over 2. So it's x to the exponent of 4 over 2. All right. And we move on to minus 2x. We add 1. So add 1. So 1 plus 1 is 2. So it was going to be minus 2x squared over 2. This was going to cancel, and you remain with what? Minus x squared. So that was it, and you can apply your limits. So that's our ax. Substitute 0 in place of x, 0 to the power of 4 over 2 minus 0 squared. Then in place of x, we're going to substitute our lower limit -1 in place of x. So that's -1 to the power of 4 over what? Over 2 minus, in place of x, substitute -1. So it's -1 squared. So meaning to say you're going to simplify each part separately. This is going to give us a 0 minus. You simplify this. That was going to give us positive 1 over 2. All right. Not a positive, but let's see. 1 over 2, it was going to be like this. 1 over 2 minus, this is -1 squared. -1 squared is going to give us a positive. So it was going to give us a -1/2, all right? A -1/2. And we can simplify minus and minus, that's a plus. So that's, we're going to have 0 plus half, which is what? Which is a half square units. So this is the area that you were simply going to have at the end. All right, integration, one of the easiest topics, because you just need to follow up. The concept is just follow up. All right, let us look into 5.3 as we are still on our integration. We had 5 marks there on 5.3. Integrate this or determine this integral. All right, there is e to the exponent of x in the denominator. So let us try to separate that That's e to the exponent of 2x over e to the exponent of x minus e to the exponent of 3x over what? Over e to the exponent of x. Knowing that we are dealing with the same base, we are going to subtract the exponents. So you subtract exponents, 2x minus x, and that's e to the exponent of x. 3x minus x, and that's going to be e to the exponent of what? 2x. You subtract your exponents, then you can integrate. Remember the integral of e, it is that e over the first derivative. So e to the exponent of x over the first derivative of x, which is what? Which is 1. So it was going to be e to the exponent of x. Another one, e to the exponent of 2x over the first derivative of x, which is what? Which is 2. Then you need the constant of integration, just like that, an exponential. You have integrated that exponential over the first derivative of what? Over the first derivative of x. So 5.4, evaluate this, right? There we are given this pi over 2. You know that you have got radians there. You're going to deal with radians, or you can just convert them to degrees. But anyways, let us see what we have. Integral of sine 2x, sine of 2x times cosec of x, all right? So with respect to x. So here, sine 2x, this, we do not have any integral that is direct for this one. So you're going to try to simplify it. Remember, sine 2x is a double angle, this one. Sine of 2x, which is equivalent to, unfortunately, you are not given that in your formula sheet. So meaning to say you must know this one by head. Sine of 2x is equal to 2 sine x cos of x. So you're going to substitute this with its equivalent. 2 sine of x cos of x times cosec. Cosec means 1 over what? 1 over sine. This is 1 over sine of x. All right, so you're going to simplify this. As we can see here, same as over 1. So you can cancel sine and sine, numerator, denominator concept. So that was going to give us what? That was going to give us 2 cos x times 1, which is what? 2 cos x. So as you can see, guys, all of that part reduces to 2 cos x, and we can integrate a cos. Remember, when you integrate a cos, it's going to give us a positive sign. So that's sine of x that you're going to have there. So this is sine of x that you're going to have at the end, 2 sine of x. Just like that, then you can use your limits. Pi over 2, 0. Like I said, you can, when you've got this pi over 2, these are radians. But if you want, you can convert to degrees. Pi over 2, pi is 180. So 180 divided by 2 is what? 90 degrees. So you can use 90 degrees. Or if you use that pi over 2, you must change your calculator to radians. You must change your calculator to radians. If you use this pi over 2, you must change your calculator to what? To radians, like this. If you check on our calculator here, we can see that there is a D. It's for degrees. So we must change that one to radians. So shift setup, radians is number 4. So you press 4. And now it's going to show R there to show that it is in what? It is in radians. So you can simplify 2 sine pi over what? Pi over 2 in radians, like that. Or you just have to convert to degrees and use your calculator under degrees. So this was going to give us a 2 minus 2 sine 0. 2 sine of 0 is going to give us what? A 0. So that's 2 minus 0, which is what? Which is 2. So this is what you're going to have at the end of the day. All right. So those are the typical questions that you might be given. As you can see, it was an exam question, November 2025. exams, so they can ask similar questions as well in your final examinations, as long it is your N4, as long it is according to your syllabus. These questions will be just a repetition. They repeat same formality. So just revise as many questions as you can know, all the basics, and to revise also those grade 12 mathematics videos. They can help you because it's one and the same in case for those who want to dual match into this mathematics. All right, so that is it, guys. Let us do revise as much as we can as we are preparing ourselves for the exams that are ahead of time till we meet again.